Ladies and gentlemen, temperature measurement is very important for various applications such as in industrial field and environmental monitoring. Due to its advantages, optical fiber-based temperature sensors have been developed using various techniques such as wavelength modulation and intensity modulation technique. Wavelength modulation technique is attractive since it provides high accuracy. However, most of wavelength-based technique require complex fabrication and interrogation system. Meanwhile, intensity modulation technique-based sensors are usually simple. On the other hand, it suffers from intensity fluctuation which come from various sources such as light source fluctuation and fluctuation from fiber bending. To overcome those problems, we proposed intensity modulation technique temperature sensor with dual wavelength compensation, which we called as intensity-based Mach Zehnder interferometer plastic optical fiber sensor. MZI was basically designed by splitting input light into two different path lengths by branching the light path. Due to the difference in path lengths, light propagate with different phase. The branches are then recombined so that interference occurs in the output. Light splitting can also be done by forming fiber taper. In this work, MZI was developed by using two tapers with different waist diameters separated at several distance. MZI output light depends on temperature due to the thermo-optic effect. In addition, the output intensity is also wavelength dependent as a result of light interference between core modes and cladding modes. By observing output intensity at two different wavelengths, dual wavelength compensation can be accomplished. MZI was constructed in SI-POF with core diameter of 980 micrometers. The core material and cladding material are PMMA and fluorinated polymer with refractive index of 1.49 and 1.41, respectively. Tapers were formed by heating the POF using solder at temperature of 80 degrees Celsius at two different points and then fulling. Sensor characterization was done by placing the sensor in our modified temperature-controlled oven while the tips were connected to spectrometer and LED. The temperature of the oven was increased from 35 degrees Celsius to 85 degrees Celsius with increment of 10 degrees Celsius and was kept at each values for 1 minute before being further increased. The spectrum was recorded every 1 second. The sensor was then taken out from the oven and let it in room temperature before conducting characterization for decreased temperature. The cycle was repeated for 3-time measurements. Here is the microscope image of the fabricated sensor, which are the first taper and the second taper. To evaluate the sensor performance, transmission at wavelength of 455.28 nanometer, 464.11 nanometer, 501.68 nanometer, and 585.86 nanometer were observed. It is shown that as temperature is increased to 75 degrees Celsius, the transmission at the whole wavelength range also increased. However, at wavelength of 85 degrees Celsius, the transmission decreased due to deterioration in optical as well as physical properties. Sensor sensitivity to temperature change was observed in terms of transmittance ratio of a pair of selected wavelengths. It was found that transmittance ratio for lambda 1 over lambda 2 has a very weak linear fitting to temperature, which is 0.1718. Therefore, lambda 1 over lambda 2 was not considered for further characterization. Clearly, lambda 1 over lambda 3 provides highest sensitivity, which are 1 times 10 minus 3/75 degrees Celsius. Meanwhile, transmittance ratio for lambda 3 over lambda 4 provides the highest linearity. It was also found that the sensor experienced hysteresis. The main factor that contributes to the high hysteresis is the fluctuation of the oven temperature. As conclusions, the sensor has comparable sensitivity to other intensity-based sensors. Relative high hysteresis behavior occurred mainly due to temperature fluctuation in temperature chamber. The sensor has advantages of a robust, simple fabrication process, low cost and low power loss. Thank you.